Okay, today we're going to start a new chapter, chapter 7, and the first section, the whole chapter is about solving equations and inequalities, more complex than what we've done before. This first section is on solving equations that have variables on both sides. Okay, our first example I'm going to do with this sort of visual representation. What we have here is a balance scale. We've talked about seesaws before with equations and wanting to keep both sides of the equation equal. So what I have here is I've got 4 green boxes on the left side of the balance scale. All the green boxes are supposed to be the same size, but we don't know what size those are. And then I have a triangle on each side, a triangle of, let's say we're talking about pounds and weight. So we've got 4-pound weight on the left side and a 36-pound weight on the right side. And with these things on both sides, the green boxes and the triangles, the scale is balanced. Now if I asked you to figure out how much does one box weigh, if there was a way that you, for instance, could take away the 4 pounds from here and also take away 4 pounds from the right-hand side so that now you only had a triangle weight that weighed 32 pounds, that might help you. And then you notice that there are 4 green boxes on the left and 2 green boxes on the right. So if you removed 2 green boxes on the right and also 2 green boxes on the left, you still have both sides of the balance scale being equal. So right now, you've got 2 boxes on the left, and you've got this 32-pound weight on the right. Here, I'll draw the green here. Okay, so if you were then to try to figure out how much each green box would weigh, if 2 boxes weigh 32 pounds, then you could pretty easily see that if I divide both sides by 2, I will get 1 box equals 16 pounds. Now I'm not going to ask you to draw these balance scales for each problem, but it's a nice visual way to figure out what it is you need to do. And if you'll notice, what we did was we started with boxes on both sides of the equation. The boxes are the unknowns. Those represent the variables, and the weights are sort of the constants that you can add to both sides. So this particular problem might have been represented by this equation. 4n plus 4 equals 2n plus 36. Notice that the n stands for a box. So there were 4 boxes plus 4 pounds equals 2 boxes plus 36 pounds. So if we were to sort of mimic what we just saw in the drawing, we could gather up all the boxes on one side. It doesn't really matter which order you use. You could gather up the boxes first of all. So for instance, if you were to subtract 2 boxes from one side, or 2n from one side, and from the other side, you retain the equality of both sides. Let's just get a little bit more space here. So now we have 2n plus 4 equals 36. And then we're going to want to subtract the 4-pound weight from both sides. Subtract 4 from both sides. We get 2n equals 32. And then we're going to divide both sides by 2. And that's how we get the n equals 16. We can always check whether our answer is correct by plugging back into the original problem. So we plug in 16 every time we see n and see if both sides are in fact equal. So I'm going to do that over here on the left. 4 times 16 is 64. Is 64 plus 4, does that equal 32 plus 36? So we've got 68 equals 68, so yes, that checks. Okay, these next problems are going to not take as long because we're not going to draw everything out on a balance scale. But our goal is still to gather up all of the variables on one side and all of the numbers on the other side so that we can solve as we have in earlier chapters. So let's go ahead and gather up all the x's on one side. It doesn't really matter which side you do. I'm going to add 8x to both sides. So we end up with negative 15 plus 14x equals 13. Notice that negative 8x plus 8x equals 0. Then I'm going to add 15 to both sides. This is all so that we can isolate the variable, as we've done all year long. We get 14x equals 28. Divide both sides by 14, and you get x equals 2. You can go ahead and check that on your own. It is correct. Why don't you go ahead and pause the video and see if you can figure this one out, and then turn it back on and check it. So here I want to gather up all the n's on one side. I'm going to subtract 1.5n from both sides. So on the left-hand side, these guys cancel, and I'm left with 12. On the right-hand side, I have to figure out what 3 minus 1.5 is. So if you're not sure, you can always do the subtraction and get 1.5. Now, 12 equals 1.5n. How are we going to solve that? So for this, you want to get rid of the 1.5 in front of the n. You want it just to say 1n. So I'm going to divide both sides by 1.5. This is one way to do it. There's, of course, other ways to do it. So 1.5 divided by 1.5 is 1. So we have 1n equals 12 over 1.5. Unfortunately, that's not in simplest form. We have to figure out a way to get rid of the decimal that's inside the fraction. So imagine multiplying both numerator and denominator by 10. What does that do? It moves the decimal point to the right one space. So I end up with 120 over 15 equals n. You then want to reduce that to lowest terms. 15 actually goes in evenly to 120 8 times. So you end up with n equals 8. We're using the same process as we would to solve any equation, in that we are trying to isolate the variable and get the variable alone on one side. So you have to gather up all the variables on one side and gather up all the constants, or the numbers, on the other side. Okay, let's try this one. Go ahead and pause the video. Notice that you have several different terms that have y's in them. Once you've finished it, turn the video back on and check your answer. Okay, so for this one, I would go ahead and combine these two. 8y minus 10y is negative 2y. Then I'm going to subtract 3y from both sides. These guys will cancel. Negative 2y minus 3y is negative 5y equals 25. And then I'm going to want to divide by negative 5 so that I have a coefficient of 1 in front of the variable. So I end up with 1y equals positive divided by negative is negative 5. Okay, here's a problem that has fractions involved, but you know how to add and subtract and multiply and divide with fractions. So go ahead and pause the video, try it on your own, and then turn it back on and check your work. So this one, I'm going to want to gather up all of the variables on one side. So I'm going to subtract 2/5 n from both sides. Okay, so what does that do on the right side? On the right side, these guys cancel, right? They make 0, and I have 16. On the left side, I have to figure out 4/5 minus 2/5. If you write that over here, 4/5 minus 2/5, since they have the same denominator, you can simply combine the numerators. 4 minus 2 is 2. I end up with 2/5. So I have 2/5 n minus 8. And now I want to get rid of that 8 that's on the same side as the variable, because my goal is still to isolate the variable. So I end up with 2/5 n equals 24. So now I got to get rid of this 2/5 on the left. I want it just to say 1n. So one way is to divide by 2/5, but dividing by a fraction is the same as multiplying by the reciprocal. So that's another sort of shortcut way of solving this. Because look what happens here on the left. When you multiply 5/2 times 2/5, you get 1, right? So you end up with n equals, and again you can reduce here as well. 2 goes into 24 12 times. 12 times 5 on the numerator is 60. And that's your answer. Okay, let's do one more problem. This is a word problem. Here we know that Sid works for a delivery service. He has the choice to be paid in 2 different ways. With Plan A, he earns $5 per hour plus 75 cents per delivery. And with Plan B, he earns $7 per hour plus 25 cents per delivery. How many deliveries must he make to earn the same amount with both plans? So here you're going to want to figure out what the cost structure is for each one. So let's say we've got Plan A and Plan B. So for Plan A, he makes flat out $5 per hour plus 75 cents per delivery. So maybe we'll call D the number of deliveries. So in this plan, if he were to make one delivery, it would be 75 cents extra. 2 deliveries would be 2 times 75 cents. 3 deliveries would be 3 times 75 cents. You get the picture. So however many deliveries, you've got to multiply that by 75 cents per delivery. So it's going to be $5 plus 75 cents times the number of deliveries. For Plan B, he makes $7 plus 25 cents per delivery. And the question is, how many deliveries must he make to earn the same amount? So here's where you can actually set them equal to each other. So 5 plus 0.75D, you want to know what number of deliveries, or what would D be, in order for those two plans to have him earn the same amount of money. So now you've just got the same kind of problem that we had before, where you have an equation with variables on both sides. So you're going to solve it the same way you did before. Go ahead, pause the video, solve it, and then turn it back on and check. I'm going to gather up the D's all on the left-hand side. So we have 5 plus 0.75 minus 0.25. Think of 75 cents minus 25 cents. That would be 50 cents, right? So we got 0.5D. 0.5 is the same as 50, or 0.50, equals 7. Notice that these two cancel each other. And then I'm going to subtract 5 from both sides. And I end up with 0.5D equals 2. So now we got to get rid of the 0.5 coefficient in front of D. So there's several ways of doing this. You could divide, for instance, by 0.5. Just be super careful here. These guys cancel, the 0.5, so you end up with D. What is 2 divided by 0.5? So let's think about that. You could imagine multiplying both sides, top and bottom, by 10. That becomes 20 over, and then 0.5 times 10 is just 5, because you just moved the decimal. You're basically just moving the decimal over to the right one. So 20 over 5 equals 4. So he would have to make 4 deliveries to make both plans be worth the same amount.